Welcome to today's video on section 10.5, the binomial theorem. I apologize in advance if it's a little noisy because the middle schoolers are at lunch right now and I'm on the patio doing this. So here we go. So the binomial theorem basically answers the question of how we're going to raise a binomial to a power greater than 2 efficiently. I mean, you could go like this and FOIL 4 times, but that may take a while. The binomial theorem allows you to do that without actually having to FOIL. The definition of a binomial coefficient, meaning the number in front of the variable, is n choose r, where n is the power of the binomial and r plus 1 is the term of the binomial. And we'll explain that more in detail as we do a full expansion. But this is just to get the coefficient. And it's defined as n factorial over r factorial times n minus r factorial. So if I say find 6, 2, where n is 6 and r is 2, you're going to go 6 factorial over 2 factorial times 6 minus 2 factorial. So you're going to go 6 factorial over 2 factorial times 4 factorial, which is equal to 6 times 5 times 4 factorial over 2 factorial 4 factorial. The factorials will cancel out, and you're left with 30 over 2, which is 15. So that means whatever power of the variable it is, 15 will be the coefficient. For 9 choose 3, you have 9 factorial over 3 factorial times 9 minus 3 factorial. So that's 9 times 8 times 7 times 6 factorial over 3 factorial 6 factorial. Notice the 6 factorials cancel. 9 times 8 times 7 gives you 504 divided by 6, because 3 factorial, and that gives you 84. So that would be the coefficient that goes with that term. So the binomial theorem. And the binomial theorem is used to expand any positive integer power of a binomial. So for example, x plus 1 to the 4th power. So that will be, and now understand something first, sorry, n, as I said, is the power of the binomial, and r plus 1 is equal to the term. So that's why you start with 0 for r, because the first term you'd put 0 in for r. So what that means is you're going to go 4 choose 0, x to the 4th, 1 to the 0, plus 4 choose 1 for the second term, x to the 3rd, 1 to the 1st, plus 4, 2, x squared, 1 squared. Notice the x's go down in powers as the 1's go up, plus 4, choose 3, x, 1 to the 3rd, plus at the end, 4, x to the 0, 1 to the 4th. So if you notice, 4, 0 is just going to give you 1. So that means in the end it's going to be x to the fourth, because 1 to the 0 is also 1, plus 4 to 1. So if you do the math on that, so if you do the math on 4, 1, so that's 4 factorial over 1 factorial, 3 factorial. So that's going to be 4 over 1, which is 4. So it's 4x to the third plus 4, 2. So that's 4 factorial over 2 factorial, 2 factorial, which means it's going to be 4 times 3 over 2, which is going to be 6x squared. And the 1 squared is just 1. And then 4, 3, that's 4 factorial over 3 factorial, 1 factorial. So that's going to be 4 over 1, which is 4. So it's going to be plus 4x, because notice 1 to the third is still 1. And then 4, choose 4. Those are going to cancel out and just give you 1. So it's just going to be plus 1. So it's going to be x to the fourth plus 4x to the third plus 6x squared plus 4x plus 1. And you can do that all without foiling it out. Expanding x minus 2y to the fifth. So x minus 2y to the fifth. So once again, the n is 5. So you're going to go 5, 0, and then it's x to the fifth, negative 2y to the 0, plus 5, 1, so then it's x to the fourth, negative 2y to the first, plus 5, 2, then it's x to the third, negative 2y squared, plus 5, 3, and then it's x squared, negative 2y to the third, plus 5, 4, x, negative 2y to the fourth, plus 5, 5, x to the 0, negative 2y to the fifth. So when we do this out, 5 sub 0 is just going to be, 5, 0 is going to be 1, because it's going to be 5 factorial over 5 factorial, which just gives you 1, and negative 2y to 0 is 1, so it's just going to be x to the fifth, and then 5, choose 1, so that's going to be the same as 5 factorial over 4 factorial, which means it's going to be 5. So it's going to be 5 x to the fourth times negative 2y. So then here, it's going to be 5 factorial over 3 factorial. Times 2 factorial. So it's going to be 5 times 4 over 2, which is going to be 10. X to the third, but then negative 2y squared is 4y squared. And it's going to be the same for 5, 3. It's going to be 10 x squared. And then negative 2 to the third is negative 8 y to the third. And then here 5, 4. Well, it's just going to be 5. It's going to be the same as 5, 1. So it's going to be plus 5 x, and then negative 2y to the fourth is going to be 16y to the fourth. And then 5, 5 is going to be 1. So it's going to be negative 2y to the fifth, which is minus 32y to the fifth. So when we simplify here, we're going to get x to the fifth minus 10x to the fourth y plus 40x to the third y squared minus 80x squared y to the third plus 5x, or sorry, plus 80x, because 5 times 16 is 80, plus 80x y to the fourth minus 32y to the fifth. And that is your expansion. Now, if you want to find a particular term in the binomial expansion, you can do that using the following formula. Remember, n is the power of the binomial, and r plus 1 is the term. So if I want to find the fifth term in the expansion 2x plus y to the ninth, that means n is equal to 9, and r plus 1 is equal to 5, which means basically r is 4. So you're finding 9 with n as 9 and r is 4. And then remember, it's a, so 2x to the 9 minus 4 power, which is 5. And then y to the fourth power, because y, the b is always to the r. So 9 choose 4, so 9 factorial, 4 factorial, and then 9 minus 4 is 5. So that means you have 9 times 8 times 7 times 6 times 5 factorial over 4 factorial, 5 factorial. Cancel out the 5 factorials. 9 times 8 times 7 times 6 gives you 3024 divided by 24, because that's 4 factorial. And that gives you 126. 2x to the fifth is 32x to the fifth, and then y to the fourth. So 126 times 32 gives you 4032 x to the fifth, y to the fourth. That is that particular term in the binomial expansion. Alright, I hope you enjoyed the video, and if you have any questions, please feel free to ask in class, and hope you have a good evening.